Boom, video key. It's time for the video key. What is this? Oh, I've got to use these tools. All right, first one's a dilution problem. We're going to do these really quickly. Not very much talking. You guys have watched a lot of videos today. As you can see, I turned the liters to milliliters. Solve for C2. Now I'm just going to plug my numbers in there. C1, V1, V2. I get to 3 sig fig 0.00129 moles per liter. Okay. And that is a smaller number than our initial concentration. Okay, we've got another dilution question. C1V1 is equal to C2V2. OG concentration, don't know. Volume of the first system, 350 milliliters. Concentration of the second system, really small. Volume of the second system, really big. I'm going to turn that to milliliters. Actually, you know what? Let's do something different. I'm going to turn this to liters. That's probably faster. Divide that by 1,000, and now I can leave my volume in liters. Perfect. Yeah, so I just converted my milliliters to liters, solving for C1. Divide both sides by V1, and now I can plug my numbers in. So C2 decimal 004 times 90 divided by 0.350. Okay, I get to 3 sig figs 1.03 moles per liter. Awesome. Okay, moving on to the next problems. All right, ion concentrations of a scandium nitrate. Okay, so first off, we got to write scandium nitrate out. Scandium nitrate. Scandium is 3 plus. Nitrate is 1 negative. Okay, that's going to break into 1 scandium ion and 3 nitrate ions. So if we start with 0.2 here, these are in the same ratio, right? Tough to see. So those are in the same ratio, 1 to 1. So their concentration is the same, 0.2. Now, comparing that to this one, we have 3 times the amount. So I'm going to times it by 3. 0.6 moles per liter. All right, another ion concentration one. That's not mole per K. All right, so I'll fix that for your guys' assignments, mole per liter. Sodium phosphide. Sodium phosphide. Sodium is 1 plus, phosphorus is 3 negative. So when that dissociates, I'm going to get 3 sodiums and a single phosphide ion, which is 3 negative. So we have 0.3 moles per liter here. Now, this one is balanced for only 1. This one is balanced for 3. Times by where you're going, 3. Divide by where you've been, 1.9. Now, if we look, this is balanced also for 1. Those two are the same, so their concentration is the same. 0.3 moles per liter. Okay, on to the last question. Almost last question. You were assigned. Okay, a little bit tougher. We've got sodium carbonate. We're going to have to dissociate that. And we're not given concentration. So this is like one of the tougher ones I did in the work. Okay, so shadow is hiding. There we go. So we got sodium carbonate. Sodium is +1. Carbonate is 2 negative. That will yield 2 sodium ions and a carbonate ion. Okay. Now we have to figure out what the concentration of this is to start with. 3.4 grams. I'm going to turn that into liters, and I'll need the molar mass of sodium carbonate. Okay, so quickly calculating that, I get 105.99. Same molar mass as the one that we did in the lesson. Okay, so I've kind of ran out of room. here, but we need the concentration of this substance before we can move on. So I'm going to cheat a bit and do the math down here. So I'm going to flip the molar mass to get moles on top, and to get rid of grams by putting grams next. And I'm going to put the volume on the bottom because I need moles per liter. Grams cancel, and now I've got moles per liter. So 3.4 divided by 105.99 times 0.9. Okay, I wind up with a fairly small concentration, 0.356 moles per liter. Okay, now I'm going to erase this stuff up here. You would have listened to this already, and then that'll give me some more room. Okay, erase that. So the starting concentration of this is what we just calculated right there, 0.0356 moles per liter. Now when I go to the next concentration, if we look, it's 2 to 1. So I've got to multiply that by 2. And I get 0.0713 moles per liter. I'm just going to double check that because I didn't round. I kept my unrounded answer in. I think it's going to... Oh, no, wait. Whoa. 0.035. I did something messy here. Let's see here. 0.356, decimal 0356 times 2. Yeah, 0.7712, I guess, if you use my rounded number. 713 if you don't. Now, this is in a 1 ratio. This is in a 1 ratio, so the concentration is the same. Okay. That is the key. If you want the answer to the bonus question, you've got to tune in to the Google Meets today.